So this is the next episode about color scans. Today we are going to do a color scan based on the fixed scan mode with the Pro HD, and I want to show you the effect on the quality of the texture, sharpness, blurring, etc. if you will use a tripod, because actually this tripod will help you to get the maximum out of your resolution that the sensor from the color pack can deliver. So as you can see here, we have here additional components. These two guys, including the cables, are the industrial pack. This is as well available for the EinScan 2 Plus, as well one of the Pro versions, and we're going to mount the scanner with the color pack that's already mounted. We're going to mount it into the tripod. Afterwards we will have to adjust the length of the feet. This should be fine. Make sure that it's stable. If you're going too much down, it can happen that you will have some undefined, let's say, contact between the table and the tripod, and it can be wonky. So just try to avoid that. Of course we have to plug in the cables. The scanner is already connected from our last video. And this is a USB 2 cable. We can just use the ordinary one. I got to reconnect the power from the Pro HD. And I got to find a more or less suitable position for the scanner. And of course there is another power supply that I have to connect for the turntable. So just some details to make sure that, for example, the scanner is mounted in a stable way. Just unlock it, just open the screw, unlock it, and if it is not fixed the right way, just tighten that fixation screw. Just pull back that security lock, and right now the handle in itself is stable. You have down here, you have some possibility to tighten or untighten the ball, that position ball. Just make sure that this opening is directed towards your turntable and your object. Just let's prefix it. This screw on the other side is opening up the degree of freedom for rotation just. Okay, to be judging if we are in the right position regarding the distance to the scanner and the right angle, of course we have to turn in the camera, and we should check it. Right now we open up the EinScan Pro HD software and we are going to opt for fixed scan mode. We're going to use a new project. As explained already, we're going to create a project-based folder. Fix scan Apple. Texture. And remember that this scanner is always regarding the folders as the file for the working. That means the folder is carrying all the information that you need for reopening up your scan and your results. That means if you need a copy, just a revision copy, copy the whole folder to be sure that you keep every data that you captured as well. Okay, so we're selecting this one and we are going to opt for texture scan, as we want to see how good the Apple will look after a fixed scan is helping us to keep calm our scanning process. And right now we see here the preview window on the left side from the cameras. That is the left camera in this case, but both of them will be synchronized. And we have here additional options. That means turntable on. We say yes. We can choose different modes on the turntable. We can say just do the alignment according to features. That means that you will use an unregular surface that will be organic, for example, to do the first alignment of the scans. Or of course you can use turntable coded targets. That's pretty cool because this turntable got targets on it. Of course this is limited to some special size. If I have a size of an object that's too big, it will cover all the targets and we will not be able to use it. But this is actually the best way how to use it, if possible, if it's possible regarding your object size, in my opinion. And you can use markers, but in this case markers are not the turntable markers, because this is coded markers like it's written there. If you will see any coded markers in any kind of scanning projects, I will just take a different position for the scanner so you will be able to see me better. If you will see markers in a photogrammetry job or anything else that have this strange kind of a point in the middle, in the center, and they have some segments around in different size and different angle orientation, you have coded markers. And why are they there? Because they are unique to the system. That means it gives the system a one-of-a-kind possible orientation of the turntable, and it makes alignment for the software very easy, because you can do the registration or alignment, how you want to call it, regarding these different targets, and this is quite helpful for the speed of the system and the preciseness. So we will put our object on our turntable, and you will see here, I just can put it a bit more around. You can see here is a cross. I'm not sure if the camera is capturing that well. In the center of the apple, more or less, you can see it here on the preview window. And this cross should be in the center of your object. That means if it's not, just take the handle to secure your scanner that it's not falling down in an undesired way, and just try to put your object in the center. And you will see as well that there is a difference regarding that size or the position of your cross and the size of that red area here, the center. And it's as well having some meaning regarding the optimal distance from the scanner to your turntable. That means if they are in close position, you are in the best position regarding sharpness of your camera. And I can go back and you will see that they will move towards each other, and this is generally positive. The problem is that you can imagine if I go further away, it's getting better and better. I just can adjust it in some better way. If I try to optimize it in this case too much, I am more in the middle of the scanning center. On the other hand, I'm just losing a resolution per inch. That means that sensor is a fixed resolution sensor, of course, and like in a camera, I can capture more details coming closer to your object that you want to capture. Of course, if you are coming too close, you're sacrificing sharpness, and this will not increase the quality of your scan either. So there is, let's say, some optimum where you are fine. I think this could be a cool update for the software as well, to have some, let's say, indicator on the side here for the fixed scan, or in any case about the fixed scan, it's nothing there that tells you you are maybe for a small part or big part in your sweet spot. Because I can of course move farther away, but I will have in the end an object that's getting smaller and smaller regarding the size of your field of view, and it will not help me. For this scan we should be fine. We'll just go a bit more with the center and the field of view, and I have the same option like I have it in the other scan. For example, that rapid scan that we did before, we can adjust the sensitivity of the sensor from the cameras, and we see that increasing it will over brighten the picture, and it well is not what we want. For this case, in the case of scanning texture as well, we can activate an HDR mode, and this is maybe quite well known for the guys of you who take pictures. HDR is a mode where you're capturing with different sensitivity parameters one picture, and you are adding them together to some homogeneous, let's say, picture that's actually a result of many pictures, but with a, let's say, homogenized brightening on all the areas. If you want to know more about HDR photography, take a look in Google. I will not go through all of it because it's a bigger topic, but just capture in your mind that this helps you to find the right sensitivity for the sensor by an automatism, and this is very, very useful for as well texture capturing. And you see, after activating HDR, I cannot change that sensitivity anymore of the sensor because there is done an automatic process of some steps, and we are not part of this anymore. Okay, we use coded turntable markers. I think this is best if possible. It means markers that's visible around. They give the best, let's say, feedback regarding the position. The apple is more or less stable on the table. Regarding the steps, it means we are right now having a parameter of 30 steps for the whole objects. It means he's incrementing that 360-degree turn into 30 increments, and this is, let's say, something where you're taking a lot of scans. What is perfect for objects that are very complex, that have a lot of, let's say, small details that need lights from different angles and so on. But if you have simple objects like the apple is one, you can even go to 15 or less, because there will not be covered too many areas in one shot by any kind of the geometry that's complex. Just something, keep it in your mind. You can just spare some time in processing by just thinking if you need so many steps or not. We're just going to start with 15. I can use existed axis alignment that he will use as well. The turntable axis, he will try to find a center and use it the turning one, but I don't have this option using coded markers, and I think it's just the second best. So enough for so far. Let's see if he's going to scan it the right way. So we are going to start the scan, and right now we see everything's going to be automatic. And during the scan process I can zoom in and out. During the process you can follow this progression on these numbers. Here's 13 of 15 scans done. So after the first orientation is done, we are just going to scan that apple from a second orientation. Therefore I'm using that plastilene to be sure that it's not moving too much, because it will not be stable putting it sideways. And I just recommend to do 3 points of support to make sure that it's not moving too much. The process is the same. I'm just going to start the scan. And the good thing about this automated turntables is really that you could go and take a coffee or write some emails while you are processing a scan. I'm just going to turn that apple one more time for the last view. I just turned around that apple again 180 degrees and just finishing my third round that I'm going to use, and after that we should be fine for a complete watertight motor. Just keep in mind that on one hand, if you do more rings, that means more orientations, you get more angles and views, that means small details get captured a little bit better. On the other hand, that advantage of having one small detail scanned from different views is compensated, on the other hand, from some error, let's say superpositioning. That means maybe in your own scan projects you already realize it's not always recommendable to scan the same area many times. That could lead to some unprecisenesses by the tendency of the software to homogenize your results and approximate them to each other. This is our third and so far last view that we scan in this case, and we are just going to unshow the other ones to be able to cut out effects and geometry from the scanning plastilene that we are using. I think that looks okay. just keep in mind that the overall result will be calculated using the different parts, and the texture will be homogenized. That means highlights are overbrightened areas or so will be compensated in the case even if you will not use HDR in the next steps. So we are going to use the global optimization to bring together that views in the best way possible. Imagine each scan like a shell, and these shells are superpositioned to each other. That means they have some geometry based, let's say, contact, and this will be in a small range fine optimized in this process. That means that superposition overlapping will be brought to a minimum by some small exchanges of position. It's fine, and we are going to calculate a mesh model right now to see what we can expect from the ready model. We are going to say water type, we're going to say high resolution in this case, even if it means high mesh resolution in this case. That's maybe something we wouldn't even need, but we can later on still go smaller regarding the poly count. That's always possible, and in small objects like that we will not have a big calculating difference regarding the end result. But keep in mind one thing, it's a bit like in photography. It's always better to have the best starting result and after that do the compression, and it's the same in the simplification of mesh. It means if you don't mind waiting too long or a bit longer here, in this case doesn't make any difference because it's a very small object, not so big poly count. Even in the raw model, it's always best to start with a high resolution scan and simplify that, because that primary information was there in the data set, and that, let's say, simplification algorithm can be chosen the right way, but the primary information is getting worse during that process, let's say, by a constant degree. And if that level where you start from is, let's say, just going down for a constant degree, it's a big difference if you start from a high level optimization or a low level optimization, even coming to the same poly count in the end. Okay, that's fine. I'm just using the standard parameters. Smoothing means if I have a very noisy or, let's say, rough surface that I don't want to have, I can just go here to medium or high. Small objects, floating objects would be objects around that are not connected to our main motor. I just don't have it. I just don't need to change anything. If you have, let's say, pieces of scanning plastilene or geotex, whatever you want to eliminate, it's possible like this as well. Just ramp up that value and they will disappear. And of course you can make disappear your object if you make it too big. Maximum triangles, you can just from the beginning limit that amount of triangles poly count. That will be the result in the case that you fear of going very high, but this is surely not the case here. Removing spikes. Spikes are small kind of a peaks out of the mesh that will be the result of scan errors that the software will detect as scan information. That means you have a flat surface, there is one point scanned wrong because of some reflection or problem, and he will make a mesh using that point, and you can just say don't use that. So remove spikes is mostly fine. Removing or filling marker holes is not possible because there are no marker holes in the object. Recommended parameters, if you change anything, to just check out if it's better for you to change that filters here. You can always, by double clicking this parameter, like I always mention, go back to your 0 point that's defined by the manufacturer, and that's mostly a good starting point if you're not sure about it. So we say apply, and we're going to calculate the final result. but nevertheless we will compare the results to the rapid scan result that we did before, the textured one, and you will pretty easily realize that you have here more visible details on that scan. So if you think about purchasing a scanner, for example AR and VR projects, and you just want to use that scanner to get a detailed, high detailed resolution surface for derivating an additional PBR map. Just one thing before you go to optimize the texture itself and the geometry, you have here the different parameters that you can adjust as post-process values, and this is as well possible and available for the texture. You can do the basic adjustments. We're just going to do simplification. You can just fine adjust that desired size. You will receive OBJ as a textured model, so we can just go down in the size of the data by simplifying that poly count. Unfortunately, the software is not able to go deeper into the modifications of the texture. I can see as well how the result looks without texture, but as you can see, it's pretty detailed.